Welcome to the Deep Dive, where we explore the most fascinating research in sound and speech tech.
Always something new and exciting popping up.
Today we're diving into the latest breakthroughs, straight from the ArcSys preprint server.
Fresh from the minds of brilliant researchers.
Get ready to explore the future of hearing aids, music composition, and AI that understands baby cries.
Sounds like a plan.
Let's start with something that I'm sure many of you can relate to. Trying to use voice commands in a noisy environment.
A constant struggle.
Imagine a speech recognition system that not only hears you but also sees your lips move.
Now that would be game-changing.
Researchers have actually managed to enhance the Whisper speech recognition model with what they call LoRa adapters.
LoRa adapter?
Yeah, there's like specialized modules trained on specific types of noise like traffic or cafe chatter.
So it's like giving the AI different filters for different environments.
Exactly. Depending on the environment, the model swaps in the appropriate adapter.
Clever. Makes sense.
And get this, it significantly improves accuracy.
I bet it does filtering out all that background noise.
And the best part is this new approach uses 88.5% fewer trainable parameters compared to traditional methods.
Wow, that's a huge difference.
Yeah, it means it can run more efficiently on devices, potentially using less power and responding faster.
A big win for anyone who relies on voice commands or speech recognition.
Now let's switch gears from speech to music.
Always up for a good melody.
Have you ever wondered what makes two songs sound similar?
I've definitely thought about it, but never really figured it out.
Well, researchers are diving deep into this question.
Really? How are they approaching it?
Instead of looking at the overall sound of a track, they're breaking it down by individual instruments.
So they're isolating different parts of the music.
Exactly. They conducted a large-scale listening test with over 586 participants.
That's a lot of ears.
And they discovered that perceived similarity actually changes depending on which instrument you focus on within a track.
So two songs could sound similar to me because of the guitar parts, but someone else might hear them as completely different because they're focusing on the drums.
Precisely. They also found that rhythm and melody have a stronger impact on perceived similarity than timbre, except when it comes to drums.
Interesting. So drums are the exception.
It seems so. This research has interesting implications for music recommendation algorithms.
Yeah. It could help streaming services suggest songs you'll actually enjoy.
Absolutely. Speaking of enjoying music, let's talk about some exciting developments in hearing aid technology, specifically cochlear implants.
Cochlear implants have come a long way.
Researchers are using something called deep recurrent autoencoders to compress the stimulation patterns of cochlear implants.
Deep return what now?
It is a mouthful. But basically, these autoencoders are learning to represent those complex stimulation patterns in a much more efficient way.
So it's like creating a streamlined code that the implant can understand more easily.
Exactly. Yeah. And this has huge implications for people with hearing loss. This compression could lead to significantly longer battery life for cochlear implants.
That would be incredible.
It would also make wireless streaming smoother. Imagine being able to enjoy music and podcasts for hours longer without worrying about your battery dying.
That would be a game changer for so many people.
As we become more reliant on devices and technology, privacy becomes even more crucial.
You can't be too careful these days.
What about those of us who use voice assistants but are concerned about who might be listening in?
A valid concern for sure.
Researchers are working on solutions to protect your privacy when using voice-activated devices.
I'm all ears.
One promising system is called XYZ. It's an edge cloud system, meaning it works both on your device and in the cloud.
So it's not just relying on the cloud for all the processing.
Right. XYZ cleverly masks sensitive entities in your speech before sending it to the cloud. It filters out personal information like names, addresses, and even financial details locally on your device.
Like a privacy shield right on your device.
Exactly. And the results are impressive. It achieves state-of-the-art speech transcription performance while filtering out a remarkable 83% of private entities locally,
That's pretty amazing.
ensuring that your conversations remain confidential.
I'm glad someone's taking privacy seriously.
Now let's shift gears again and explore how analyzing someone's description of a picture can reveal signs of cognitive impairment.
That's interesting. I didn't know that was possible.
Researchers are going beyond analyzing the words someone uses and are using spatiosemantic graphs to track the visual narrative path of speakers.
Spatiosemantic graphs.
It's basically a way to understand how someone's description moves through the different elements of an image, even without eye-tracking technology.
So they can understand how someone visually processes the picture based on how they describe it.
Exactly. What's remarkable is that this automated approach can distinguish between cognitively impaired and unimpaired speakers.
That's a powerful tool for early detection.
It has the potential to be a valuable tool for early detection and intervention, allowing healthcare professionals to provide support and resources sooner.
Early intervention is key.
Now let's dive into the world of neural audio codecs, which are revolutionizing audio generation.
I've heard a lot about those.
They do have a weakness, though.
Oh, what's that?
They tend to struggle with audio they haven't encountered before, what we call out-of-domain audio.
I see. So they need to be exposed to a wide variety of sounds.
The researchers are developing ways to overcome this limitation.
That's good to hear.
One promising approach is called complex deck.
Complex deck. What's so special about it?
Complex deck tackles this problem by modeling the complex spectrum of sound. Imagine capturing a much richer, more detailed picture of the audio compared to other codecs.
It's like going from standard definition to high definition, but for sound.
Exactly. So it's capturing the nuances and subtleties that other codecs might miss.
That makes a lot of sense.
And the results are remarkable. Even though it was trained on just 30 hours of speech data, Complex Deck shows incredible robustness to unfamiliar audio, making it a powerful tool for tasks like text-to-speech synthesis, audio editing, and music generation.
Wow, that's impressive.
As robots become more common in our lives, their sounds play a big role in how we perceive them.
Absolutely. Some robot sounds can be a bit unnerving.
A new study explored people's reactions to robot sounds.
Oh, what did they find?
Unsurprisingly, people generally dislike high-pitched, loud sounds from robots,
That makes sense.
but they actually appreciate informative and rhythmic sounds.
Sounds that give you clues about what the robot is doing or where it's going.
Exactly. If the sounds provide context and predictability, we're more likely to accept robots into our lives.
It's all about making us feel comfortable.
This research could guide the design of robot sounds that are not only functional, but also pleasing to the human ear.
Now that's something I can get behind.
Speaking of pleasing sounds, let's talk about AI-generated music.
Always a fascinating topic.
Creating realistic synthetic music, especially for instruments like the violin, is incredibly challenging.
It requires a lot of nuance and expression.
But there's a new AI on the scene called ViolinDiff that's changing the game.
ViolinDiff. Tell me more.
ViolinDiff is a two-stage diffusion model that focuses on capturing the subtle pitch bends essential for expressive violin performance.
So it's not just playing the notes, it's learning how a human violinist would actually shape those notes to add emotion and nuance.
Precisely. And the results are impressive. ViolinDiff generates noticeably more realistic violin sounds, making AI-composed music more expressive and engaging.
That's really cool.
Now let's turn our attention to the youngest humans. Babies.
Ah, the masters of communication.
And we all know those cries can be a mystery.
They certainly can be.
But Infant Crinet is on a mission to crack the code.
Infant Crinet. Sounds like a superhero.
Infant Crinet uses AI to analyze and understand baby cries, distinguishing between different types of cries with remarkable accuracy.
That's amazing.
It leverages pre-trained audio models and clever feature extraction techniques to identify patterns and nuances in baby cries that we humans might miss.
Like a baby translator powered by AI.
Exactly. This technology could be incredibly helpful for identifying potential health issues in infants, leading to earlier intervention and better outcomes.
That can make a huge difference.
Imagine a future where parents and caregivers have a tool that helps them understand their baby's needs, more effectively reducing stress and anxiety.
That would be a game changer for parents everywhere.
Speaking of impressive feats, imagine being able to transfer the unique singing style of one singer to another, almost like vocal cloning for singing.
Now that would be something.
That's exactly what StyleSinger aims to do.
StyleSinger, how does it work?
StyleSinger makes this possible with zero-shot style transfer. It uses a residual style adapter to capture the stylistic nuances of a singer's voice.
So it can transfer styles it's never even heard before.
This means it can transfer styles it's never even heard before, opening up a world of possibilities for musicians and producers.
Wow, that's mind-blowing.
Imagine being able to blend the styles of different singers, creating completely new vocal sounds.
The possibilities are endless.
This technology could revolutionize the music industry, blurring the lines between human and artificial creativity.
It's both exciting and a little bit scary.
And to support this rapidly advancing field of singing voice research, there's a new massive singing dataset called GT Singer.
GT Singer, tell me more.
It's a treasure trove of high-quality recordings from 20 professional singers covering 9 languages and 6 different singing techniques.
That's an incredible resource.
GD Singer is incredibly valuable because it includes not only the recordings, but also realistic musical scores and paired speech data.
So it's not just about the singing, it's about the whole package.
This makes it a versatile resource for all sorts of research, from developing new singing voice synthesis models to analyzing singing techniques and exploring cross-lingual singing.
It's going to fuel a lot of exciting breakthroughs.
GT Singer isn't the only singing AI making headlines. TC Singer is taking things to the next level, offering even more control and flexibility.
TC Singer, what can it do?
TC Singer is like a vocal chameleon capable of switching between different singing styles, languages, and even controlling the level of expressiveness in the voice.
So you could take a pop singer and make them sound like an opera singer.
Exactly. Or have someone sing in a language they don't even know, all while controlling how much emotion they convey in their voice.
That's truly remarkable.
The possibilities are truly mind-boggling. This technology could transform the music industry, allowing artists to experiment with new sounds and reach wider audiences than ever before.
It's a whole new world of musical expression.
Now let's delve into the technical side for a moment and revisit LoRa-based fine-tuning methods,
Those are pretty powerful.
which are powerful for adapting pre-trained models for specific tasks.
Right.
But researchers have discovered that sometimes LoRa methods don't fully utilize the potential of pre-trained models.
So there's room for improvement.
They've developed a spectral-aware adaptation technique that focuses on fine-tuning the most important parts of the model, taking into account the spectral properties of neural networks.
So it's a more targeted approach to fine-tuning.
Precisely. And this has led to enhanced performance in speaker verification tasks,
That's great to hear.
highlighting the importance of understanding and leveraging the inner workings of these complex AI models.
It's all about optimizing those models.
Now let's turn our attention to an area where AI can make a real difference: helping people with dysarthric speech.
Dysarthric speech.
Dysarthria is a motor speech disorder that can make it difficult for people to articulate words clearly.
I see.
Assessing the intelligibility of dysarthric speech is crucial,
Absolutely.
but it becomes even more complex across different languages.
Because the nuances of each language can impact how speech impairments manifest.
Exactly. But AI offers exciting possibilities for bridging these language barriers.
I'm curious to learn more.
Researchers are exploring a framework that combines a universal model to capture the core characteristics of dysarthric speech, regardless of language, with language-specific models that account for unique phonetic and grammatical features.
So it's a two-pronged approach.
Exactly.
Mm.
This kind of framework could lead to more accurate and reliable cross-language intelligibility assessments, enabling better communication and support for people with dysarthric speech worldwide.
That would be a huge step forward.
It's inspiring to see how AI is being used to break down barriers and improve people's lives.
Absolutely. It's amazing what technology can do.
Let's talk about AI's role in music composition now.
Always a hot topic.
Imagine having an AI partner to help you write your next musical masterpiece.
That would be pretty awesome.
That's the promise of MIDI-GPT.
MIDI-GPT.
MIDI-GPT is a generative model designed for computer-assisted music composition.
So it's like a digital muse.
It's like having a super talented collaborator who can generate musical ideas on demand, helping you overcome writer's block, or simply sparking new creative directions.
Sounds like a dream for any musician.
MIDI-GPT can fill in musical material at the track and bar level, taking into account attributes like instrument type, musical style, note density, and more.
So it can adapt to different genres and styles?
Imagine you're composing a piece and you need a drum beat to accompany a specific melody.
Okay.
MIDI-GPT can generate multiple drum beat options that fit the style and tempo of your piece, allowing you to choose the one that works best.
That's incredibly useful.
That sounds like a powerful tool for musicians of all skill levels.
It would certainly democratize music creation.
It could make the composition process more accessible and even push the boundaries of musical creativity.
I can see that.
Okay, one final topic before we wrap up this part of our deep dive.
Shoot.
We've seen incredible advancements in text-to-audio generation,
The stuff I've heard is pretty mind-blowing.
but sometimes it feels like these AI systems are a bit of a black box.
Yeah, it can be hard to understand how they work.
We often don't understand the inner workings of these systems or how they make decisions.
Mm.
But AudioGenX aims to change that.
AudioGenX.
AudioGenX uses explainable AI, XAI techniques to shed light on the text-to-audio generation process, showing us how different input words influence the generated audio.
So it's like peeking behind the curtain?
Exactly.
Yeah.
This increased transparency is crucial for building trust in these powerful AI systems.
Makes sense.
If we can understand how they work, we can use them more effectively and responsibly.
I agree. Transparency is key.
That's an important point. As AI becomes increasingly integrated into our lives, transparency and understanding are essential. We've covered a lot of ground in this first part of our deep dive, exploring a wide range of innovations in sound and speech technology.
We've explored how AI is being used to improve hearing aids, enhance privacy and speech recognition, and even compose music that rivals human musicians.
It's mind-blowing how far this technology has come.
But with great power comes great responsibility, right?
Exactly. These advancements are incredible.
But it's crucial to be aware of the potential risks as well.
You bring up a really important point. With any powerful technology, there's always the possibility of misuse.
Security is a major concern.
What are some of the security concerns we should be thinking about?
Well, researchers have demonstrated the possibility of creating a backdoor in a speaker verification system based on a Siamese network.
A backdoor. I'm not sure I follow.
Siamese networks are commonly used in speaker verification
Okay.
because they're great at comparing two audio samples to determine if they originate from the same speaker.
Makes sense.
However, attackers can exploit this
Oh, no.
by embedding a universal identity, sort of like a master key, into the model.
So anyone possessing this universal identity could impersonate any enrolled speaker.
And bypass verification.
That's scary.
It's a serious vulnerability.
Yeah, this type of attack could grant unauthorized access to systems or even facilitate fraud.
Exactly. It emphasizes the need for robust security measures to protect against these vulnerabilities.
It's a constant cat and mouse game.
For sure.
Switching gears back to the realm of music we previously discussed, Style Singer.
Right.
But there's another AI singer making waves.
Another one.
It's called Style Singer.
Okay.
Style Singer is a remarkable singing voice synthesizer capable of zero-shot style transfer, cross-lingual transfer, and multi-level style control. It's like the ultimate vocal chameleon.
Wow. That sounds impressive.
Could you break down what those terms mean for those of us who aren't AI experts?
Of course.
Uh,
Imagine being able to take any singer's voice
okay.
and make them sing in any style, any language, with any level of expressiveness you desire.
That's incredible.
That's the power of Style Singer.
It sounds like having a virtual choir at your command.
It kind of is.
How does Style Singer achieve such versatility?
Well, it uses a combination of techniques. It analyzes different singing styles to understand their unique characteristics.
Interesting.
It uses a language model to ensure correct pronunciation.
Smart.
And it has a special decoder that adapts the singing style based on your input.
So you could take a pop singer and make them sound like an opera singer.
Absolutely.
Or have someone sing in a language they don't actually know.
Exactly. The possibilities are groundbreaking.
It really is a game changer.
This technology could revolutionize the music industry, enabling artists to explore new sounds and connect with audiences globally.
It's fascinating to consider how AI is reshaping creative expression.
It's a whole new world of possibilities.
Speaking of which, data is the driving force behind these advancements.
Absolutely.
And in the world of singing voice research, there's a groundbreaking dataset called GT Singer.
I've heard whispers about that one.
GT Singer is a massive, high-quality singing corpus,
Okay.
specifically designed to facilitate a wide range of singing-related research.
What makes it so special?
Well, first and foremost, its sheer size is impressive. It contains over 80 hours of recordings from 20 professional singers,
That's a lot of singing.
encompassing a diverse range of languages and singing techniques.
Wow.
That's a lot of data.
Yeah.
What else makes it so valuable for researchers?
The level of detail and annotation is remarkable. It includes not only the singing recordings, but also realistic musical scores,
Okay.
phone-level alignments, global style labels, and paired speech data.
That's an incredible amount of information.
It's a treasure trove for researchers.
How will this rich data set impact the field of singing voice research?
I think we'll see a wave of innovation stemming from GT Singer. Researchers can use it to develop new singing voice synthesis models, analyze singing techniques, and explore cross-lingual singing.
It's exciting to think about the possibilities.
Yes.
Earlier, we discussed the importance of making AI systems more transparent and understandable.
Right.
We touched upon Audio Gen X, which aims to do just that for text-to-audio generation.
A worthy goal.
Audio Gen X offers a glimpse into the inner workings of these systems. It reveals how different words in the input text influence the final audio output.
How does it do that?
It uses explainable AI techniques to highlight influential words.
So it's like having a behind-the-scenes look at how the AI transforms text into sound?
Exactly. This transparency builds trust in AI systems.
I agree.
When we grasp how they function, we're more inclined to embrace and utilize them effectively.
It makes sense.
That makes sense. Transparency and trust are paramount as AI becomes more integrated into our lives.
Absolutely. As AI systems become more sophisticated and integrated into our lives, transparency and trust will be more critical than ever.
We've covered an impressive amount of ground so far,
We have.
but there's still more to uncover. We'll be back shortly for the final installment of our deep dive into sound and speech technology. Welcome back to the deep dive.
It's been an incredible journey through the world of sound and speech.
It really has. We've covered everything from AI that can understand baby cries to systems that can protect the privacy of our voice commands.
So much innovation happening in this field.
It's amazing to see how these technologies are evolving and impacting our lives.
Absolutely.
What else is on the horizon?
Well, let's talk about something that's close to home for us podcasting.
Okay,
Imagine a world where AI can help us edit and enhance our podcasts,
now that's interesting.
making them more engaging, more professional.
So it's like having a virtual podcast producer.
Exactly. These AI tools can automatically transcribe podcasts, identify key topics, and even suggest improvements to the audio quality.
That would save a lot of time and effort.
Absolutely. Podcasters could focus more on creating compelling content and less on the technical aspects.
But what about the creative side of podcasting?
Ah, yes. The heart of it all.
Can AI really contribute to that?
Believe it or not, AI is already making waves in creative writing. There are AI models that can generate story ideas, write dialogue, and even craft different narrative structures.
Wow, so you're saying AI could help us brainstorm episode ideas, write scripts, and even structure our podcasts.
The potential is certainly there. AI could be a valuable tool for overcoming writer's block, exploring new ideas, and pushing the boundaries of storytelling.
It's amazing to think about the possibilities.
It is. It will be interesting to see how podcasters integrate these AI tools into their creative process.
It seems like AI is becoming an integral part of podcasting, from pre-production to post-production.
I agree. The future of podcasting is going to be fascinating.
This deep dive has been an eye-opening experience. What's the one key takeaway you hope our listeners gain from this episode?
That we're living in a time of remarkable innovation in sound and speech technology. AI is changing the way we communicate, create, and experience the world around us.
It's both exciting and a little bit daunting.
Absolutely. But I believe the potential benefits far outweigh the risks. It's up to us to use this technology responsibly and ethically.
Well said. To our listeners, thank you for joining us on this exploration of sound and speech technology. We hope you found it as fascinating as we did.
It's been a pleasure sharing these insights with you.
We encourage you to keep exploring, keep asking questions, and keep your ears open to the sounds of innovation. Until next time.